Hello everyone. In this video, we are going to discuss about the least cost routing. So in the previous video, we just discussed about the what are all the networking layer routing protocols. So each and every routing protocols are working based on their own algorithms. For example, the RIP protocol, that is a routing information protocol, it's working based on the distance vector algorithm, and open shortest path it will working on the least cost link state algorithm, and then similarly for the BGP it based on the path vector. So all these algorithms are mainly focusing on the uh, to find the minimum cost for the path. Okay, so now the network we can considering as a graph. So we know already the graph how it will be working. So if we are just taking the graph, the two important thing will be there. So first one is the nodes and another one is the edges. So here the nodes are called as routers, and then edges it's going to be connecting the two pair of the routers. For example, the A, B, C and D. Okay, so here the A, B, C, D, so these are all the nodes, so we know very well, so that is considering as a routers. And then the connection between the A and B, it's having the edges, so that have some weights. Okay, weighted graph we already discussed, right? Weighted graph. So now the internet that's going to be the networking going to be working based on the weighted graph. So in this, we are just finding the least cost routing. So what is the least cost? The total cost must be least to reach the all the routers with the possible routes. So that is our main motto. So the source router and then your destination router, we need to selecting the best path, that is a route. So that should be the least cost. That is our motto. So for that, the least cost algorithm is the basic thing, principles of the all the routing protocols. So now we are just taking the routers as a nodes, right? So that is going to be indicated as n. So the least cost path for the each router to the another router, that is going to be considered by n minus 1. So how we can able to find the entire the topology or otherwise a network. So finding the least cost for the entire whole network will be n into n minus 1. This is the value. So this is the going to be denoted by your least cost path of your whole network. Okay, for example, in your um, network we are having the 7 routers means, so 7 into 7 minus 1, that is 7 into 6 equal to 42 is the total least cost path. Okay, so like this we can able to identify. So now we can solve how to find the least cost path from the each and every router to reach the all other destinations. We already discussed the um, trees concepts in a data structures, right? So in the trees concept we are just finding the minimum spanning tree. So from the root to we are just reaching the all the nodes, so we are just making the connection. So similarly now we are just going to be finding the least cost. So for this example, A, B and C, D, F and G. So connection between these, everyone is having some its own weightages. From that we are just going to be finding the least cost. So from the A to B, 2, B to C is 5, C to G is 3, and C to F 4, and F to G is 1, E to F is 2, B to E is 4, A to D is 3, in D to E is 5. Okay, so now we are just going to be find the least cost tree, that is from A. From the A router, we need to travel all other routers. So what is the minimum cost? Okay, for example, from A to A, reaching the cost is 0, and A to B, the direct connection is this. From A to B, the cost is 2, and A to C. So A to C, we can able to reach it through B with the minimum cost. So B to C, the value is 5. A to B, the value is 2. So 5 plus 2, so total is 7. And D, direct connection, so value is 3. And E. Now here A to E, we can travel through B or either through D. So now this is cost is 3. D to E cost is 5. So 5 plus 3 is 8. Similarly, if we just travel through B, A to B is 2 and B to E is the cost is 4. So 4 plus 2, 6. So which one is the minimum? So through B we can reach the E, means the cost would become minimum, right? So now we can make the connection like this. So more than one path if it is available, so we can check which one is the minimum cost. That is the main motto of least cost tree. Similarly for the F, so obviously A to B and B to E and E to F, because E to F the value is only 2. So 4 plus 2 plus 2, it's a 8. So then G, so through F we can travel, so the total value become 9. Similarly, we can find the least cost for all other routers. So now we can solve one more thing from B. Okay, so from B to B the cost is 0. B to A the cost will become 2, and B to C the cost is 5, and D same thing. So through E we can travel or through A we can travel. Okay, so through E means 5 plus 4 9, and through A means 2 plus 3 5. So this is the path is the least one. So 5, and B to E the cost is 4, and F, so through E we can reach it, so that is minimum thing 6, and again G, this is the path, the reaching cost is 7. Okay, so now the total cost now we can calculate. So all the cost if we are just adding together for this topology, um, 7 plus 3 10, and 8 plus 2 is 10, and this is 15. So totally 35 for this reaching entire the thing if we are just calculated. And here again, um, 4 plus 6 10, 5 plus 10, and 9, so 29 for this. Okay, so from the source we need to reach for the all other destination. So what is the cost it will be going to be taken for our destination? Suppose if we want to travel B to F means, so B to E and E to F, this is the minimum. So once if we are just finding the least cost, so we can easily identify the path for whenever the updation has happened. So similarly you can make the least cost tree for the all other nodes too, from the C, from D, from E, from F, and then from G. So total the cost we can find it. So based on this only the routing table, the updations are going to be happen when the protocols are going to be work on it. So this is the basic for all the dynamic routing protocol working principles. Okay, so the next video we will just working on it, uh, the dynamic routing protocols. Thank you.